A very warm welcome from our side here from Schlotau and Wauer to a new webcast. We are really happy that you joined us today. Let me just quickly introduce the different packages that we have now. So starting with Lisa S, where you can manage your projects and also do batch printing for reports. But basically, you set up basic data and your intersection layout with it, where you have numerous possibilities to adapt this to your local needs. And you have the signal timing plans here as well. Lisa M is then the next step where you can coordinate several intersections and easily set up and optimize screen waves. Then there is Lisa XL, our tool for the pros, where you also have a logic editor and test site for actuated controls, an integrated test site, and you do not have to be a programmer or such. You can just drag and drop different modules that you can create yourself or that we have in predefined libraries. And so you can easily do public transport prioritization. And other than that, we have some extra modules that you can integrate in your Lisa package as well. So there is a traffic counts module where you can easily analyze and also present in different diagrams and stuff the results of your traffic counts. What you always can do is integrate the data of the traffic counts in your traffic planning. You also have different interfaces to third-party simulation tools like Vissim, Aimson, and Freeware Sumo. And certainly, we are also on the way to the future. We have map export. We have integrated all the geographical data. You can create and export map data. And we are CITS and CCAM ready. We have a special logical library for Lisa XL and so on. Also, if you like to have a demo version after the click along so that you can try and test Lisa and all its modules and functionalities.
All right, so to give you an idea of click along, I will go through this example and show you the basic and even the advanced functionalities of Lisa. So for beginners who have no idea of Lisa and this is the first time you are seeing it, it is a traffic engineering software workstation which is designed to help you to develop signal timing plans. So that means you can develop, configure all the information needed to engineer traffic light intersection. So it was actually developed for German market. So it was a bit centered around OSIT, but it's not limited to that. And we will see that. Lisa automatically calculates the signal timing plan and does all the intergreen time calculation. So it helps you to develop these traffic actuated plans also. And it just gets you to the stage where you need to upload it to a compatible controller. We have made Lisa in such a way that it has 3 pillars, which we call as creation of signal timing plan, then you can evaluate it, and then you can further test it. So it is basically, I will come back to this window, what you see here, but just to show you these 3 pillars, you have something, you go from left to right in Lisa. So you can create a site plan here on the left side, starting here, you need give all the information which you see on a road, you put it here. Then once you have all the physical aspects of planning, you go to the planning security safety part of view, which is intergreen time, offset, conflicts point, and you create signal timing plan. And the next point is you can also evaluate it here in this point, and then you are ready to upload it on the controller. So let's get back to the starting. This is the welcome window of Lisa, which is called the project management. This is used to manage intersections and even coordinations. What you see on the left side here in this window are all the intersections which I have uploaded in my Lisa. And below here we will do coordinations, which is part of Lisa M, later part of this training. And you can create, copy, import, export these intersections and coordinations. Here we can create a new project by clicking here on plus. You create on plus, and then you have these 3 identifiers where you give the name of the town, then the intersection, and then the variant number. I have already created some examples for you, so we will go through these examples, which some of you might have got in the demo versions. This example is in city of Hamburg in an intersection. So you can, as I said, click here on plus, give some name here. Let's call it Lisa Town example, and then abbreviation, let's say 000, and okay. So Lisa created something 000 for us under Lisa Town and example. And I will open once you have created it, it's compulsory to double click on it. So you see it below in the selection list window. And once you have selected it, on the side, you see all the related information related to this intersection. So who created it, when was this created, and some additional thing. What important here is to notice that we are using the RILSA, the German guideline, but as you can see, it's not only limited to that. We have various guidelines, for example, from Netherlands, from Switzerland, Austria, Hungary, included in our LISA. So the guidelines could be adapted to needs if it is needed. Once you have selected your intersection, you save and close, and you come to configuration. So here you enter all the geometric data. I click on basic data, and this empty window comes. So first we need to enter our site plan. For this, I click here on load site plan. And then I have already saved my PDF site plan. Could be, it's just not limited to PDF. You have options of uploading image file or all the formats what you see here. You can upload them. And then I click on my example, which is already created. I click on OK. There's an option to further crop it because it might be a case when you have a bigger site plan. I click on OK, and Lisa automatically asks me if I want to enter scale now. I say yes, and here we have something to help us, which is normally or mostly not the case, scale provided to us. You can, in that case, use length of roads. Once I click on this, I can show it again how I did it. It asks me to enter this pixel to meter ratio, which is 20. In case you have to check it again or do it again, you click on scale, you click here and you drag your mouse until this here, and then you see if you are correct. You can also measure using this measure length. If the scale enter is correct, for example, you can just check from here to here. The length normally lane should be 3.5 meter. So once you have entered the lane, we look at the the scale, we look at the site plan, just for new people to understand what a site plan looks like here in Germany. So you are traveling on the right side. You have these signal groups here, V1 for facing this direction, and V2 for this, V3 here, and V4 for this direction. Then you have this P and A signal groups, which are for pedestrians and acoustic. So for visually impaired people, we have this signal groups. Then you have some on these symbols which you see are right of way to tell when the signal groups are off, which lane has the priority, which direction has the priority. This is needed for fixed signal timing plan, which is the Lisa S. And if you go 2 steps further to Lisa XL, where you are designing traffic actuated control, we also need detectors in that case. And here you see D9, D10, D1, 2, 3, D4, D5 here. These are all detectors, which you can also give in the basic data. So far, we have a picture now of what is this site plan. We can start with creation of legs. If you have already used Lisa 7.3, then you see it here already in Lisa 8. It's a bit different. We have this tab now, and all these symbols to define are in this tab. We start by defining with leg axis. We click on this. And I can start with V1. I click here and then I drag it to the end. And one leg access is created. As soon as I leave my click, my icon changes to the another one, which is the new lane. So once I simply have to click here, 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 and it creates new lanes for me. And similarly, I will do it on the opposite direction and this and this. So it creates 5 lanes for me. I will do it one more if I was too fast. So you can do it again. You click back here. Let's do it for V2. I click on this, then I click here and I drag it and leave it. And then I put 1, 2, 3. So it has create like you have to click back on the icon so you see so it's changed, your cursor is changed back. So this was the axis which I created, and here you see the properties of my axis. It tells the number which you can change here, and the right of way, I can already define the right of way. So in this case, it is the main street. This symbol in Germany is for the main street. And then I save it. And then before I go further, I would like to introduce you to these icons, what you see here. For now, what important is to click on this point, which is called intersection diagram, which gives you a summary of what has been done by the elements until now in your diagram. So Lisa, it doesn't know the site plan behind it, just looks at your elements. These are elements what you have given, and it shows you here. So as you see, we have defined these 5 lanes and 3 lanes here, and you see them here along with the right of way. All right, I would actually also do one more, so it will be more clearer. I click on leg axis, I click here, go inside, leave it, and then I start 1, 2, 3, 4, 5. As you see, they are a bit not properly done. You can always select them and move them as you want. So here. Important thing is that your stop line is exactly on the stop line here, because it will be used, the distance will be used for calculating the distance from the conflict points, which will be further used in the intergreen time calculations. All right, once I have done this, I save it again, and I look at the intersection diagram, and as you can see, I have more added lanes. We will now connect the travel paths. So here you see in our nicely made site plan that it shows that this is turning left. So here we click on this and we click on here, and it automatically creates a travel path for us. We can of course select it and reduce or increase the radius. I will do this for here you see this traffic is going straight. So I go here and I click here. And similarly, I will do this for here and here. And you can always select it and change the radius. Okay, I will do one more so you can see conflict points. I select this one, which turns left, and it goes here. And it definitely could also turn on the outer lane. So for safety purpose, I connect to both of them. And this is okay, I save it. And then if I click on the intersection diagram, you see, because of this, what the travel paths I have provided, you can see the directions of the lanes I have provided. Next thing would be to provide the transport mode for each of the travel path. So if you have a bicycle lane, if you have just the vehicle, or you have everything allowed on this lane, you can select here by clicking on this and then For example, by default, everything is set to vehicle, but you can do vehicle bus, and you see Lisa changes colors here, so it's more user-friendly. And then if you do bike, then it's again different color. And let's say if you just have a bicycle path, then you click, just assume we have a bicycle path here, and I have to draw one more travel path. I click here, and then I click on this here, and I click here, and these automatically make a travel lane to the access to the leg 2. And let's say I want to connect it to this lane, and only these two are cycle lanes. So I will select here to here, and I will make it bicycle and remove vehicle. So you see how Lisa does it. Very interactive. And then we save it, we have a look here, and then that's how it looks in my intersection diagram. All right, so I will, this is just to show you, this is not the, in our intersection diagram, in our site plan. So I will remove it for now. Okay. Once we have entered the travel path, the next part is to enter the crossing. We have to enter the crossing. Crossing is for the pedestrians here. We see 3 crossings here. But let's say we have to enter crossing here, and this is a bit, right now there are just 3 travel paths, but they could happen in a very complex intersection that there are, I don't know, 20, 30s of travel path, and it might get a bit confusing. So you simply right click here and you say hide all travel paths. So they're there, it's just you don't see them in your diagram, and it makes it easier for you to further carry on with another elements. So I click here on crossing, and then I click here, and then I can just drag it to the corners, because it's also very necessary for calculation of intergreen time that they are accurately shown in the distance. And I will do one more. I put here, simply drag, and then so I save it, and the part of crossing is also done. You can do this similarly for the next crossing. Once we are here, I will skip detectors for now, and we can go to provide signal groups for the lanes which I have given in. So as you see here, the signal group is V1A, V1, this is V1. I click here and I go to signal groups on the left window. I click on plus button, and then I give name V1. And this is the type vehicle. These are different signal types, which could vary from city to city, country to country. We have some defined signal types. And of course, you can define your signal types if needed in another module. I do OK. And then here, I can use the same signal group V1. And this here is V1L. And this is a different signal group altogether, V1L. And this is for the left turning vehicle. And you see this small arrow here. This means that when this left turning is on, no conflicting direction should be on, no conflicting signal group should be on during that time. Because in Germany, what also happens is that you can turn and the pedestrian cross at the same time. So it's called compatible conflict. But if there's this arrow, it means that when this is on, this has to be off. It's conflict. So I've defined a different signal group for this one. Similarly, I will do for one more, V2. I click on this. I click plus. V2. OK. And this here is also V2. I do save, and then I look at my intersection diagram, and you see that V1, what we have defined for the modes and the direction, and signal groups is everything is here. Okay, next we can also define the signal group for the crossing. I click on the crossing, and then plus, and Lisa automatically determines that yeah, it's a pedestrian signal groups. I can put here B2. Okay, and then again I can provide here A2, and it could be an acoustic signal. So we have P2 and A2 defined for this one. You can also define the flashing light, which is kind of a warning light. Where, as I said, the turning vehicles could cross at the same time with this crossing, pedestrians crossing. So there will be flashing light, which tells the vehicle to be careful of the pedestrians. So you can also define it here in FL2, and then you say it is a yellow flashing light. Okay, and I save it. I hope it's clear till now. I can quickly give the summary of what I did. So also if I forgot some point, they might come up. So we upload the site plan, just clicking on here. You have various formats to upload from. And then once you have uploaded it, you provide the scale. And then you start going from top to bottom. You provide the axis, then you have the lanes for each direction. And then you have the travel path to connect your travel lanes. And then you provide crossing. All right, we look at the settings here. As I said before, once you click on one, and then automatically you have the direction. The directions are provided by Lisa. How this will look like here, but you can of course change it if this is not shown correctly in this window. I think this is for the basic data, and then we can go to the next step. But before I go, I will show you that Lisa provides you an option to, once we have all the travel paths inside our defined, we can click here and window opens, which tells you that if we want Lisa to calculate all our conflicts for us, or we can do it manually. For that, I will open the intersection which I've already created before with the entire complete basic data, and which is this one. Once I click on this, you see on the comments what is included there. So every time you can see what all information is included in this. I will open the one which is selected, save and close, and this is how final intersection would look like after providing all the information needed. In this case, there are also detectors. Yeah, okay, maybe I can show you quickly how to provide a detector. We saw in our site plan that there were these D1, D2 cases. So it's simply like clicking here. From Lisa 8, you have something called visualize detectors. Before it was not possible, and now you can simply click here and click on your lane, and then you can provide detector name. You can say what kind of detector it is. There are various possibilities, mostly for documentation purpose. Then you can provide the distance and what kind of function this detector has. This will be used in your logic. I said it's a test detector. I do OK. And if I click on here, you see the properties of a detector here in this case. We can also go to the detector tab, and my test detector is included here. If I change the distance for this detector, you will see that the distance also dynamically changes on the windows on the left. And similarly, you will do it for all the lanes. I will delete it for now. And you have detectors on the crossings, which are called the push buttons. So once you click on this, you can also provide a detector, and I say push button test. And Lisa automatically knows that it is a push button, but you can still change it. And you do OK, and a new detector push button will be allocated here. All right.
Maybe at that point, the question from Camilo. He asked about now in Lisa 8 for the crosswalk, 2 additional lines are created, sidewalk or bike way. Can you tell us about this? Does it affect the intergreen times calculations?
So the sidewalk, this here is basically used for map, if I understood the question correctly. So this is something which we have, because something for CITS, we use these detectors for sending the CITS messages, but for also to include the pedestrians and the bicyclists, we have something called sidewalk and bikeway, which we can provide here in this case. And yeah, it doesn't. It's for my understanding, it doesn't affect the intergreen time calculation. The main purpose of these is for the including passengers, pedestrians, and bicyclists in CITS. But this is too advanced for a click along. All right, then I will finish here with the basic data and go further. And then normally we go to evaluation parameter, but I'll skip this for now. I'll explain later why. And we go to signal groups. So under signal groups, you can see all the signal groups defined. Here you see minimum green time. You see a 6 seconds. In Germany, we go for 10 seconds, but for international click along, we keep it for 6. You can change the initiation and termination based on depending on how you define it. That will be monitored by the operation system of the controller. And in the LISA module of signal timing plan, stage transition and test site, there you see here 2 more columns, off state green and color indication of yellow. Basically, this means that when your controller is in the activation or deactivation mode, then which direction should get right of way. Normally, it's the main direction. So off will mean that they have the priority. This color indication of yellow means, so when your controller is in off yellow flashing mode, so what should be indicated on the light? Either it's unlit, which is dark, or if it's yellow flashing. Then you have vehicle velocity maximum, which you enter the legal maximum speed, but it is only for documentation use. And here you see everything, all the signals groups which we have defined in the basic data, they appear here. You have the possibility to change the symbol if needed. As I showed you here, the intersection diagram, you click here, and then you can cross-check if everything is correct as you defined, otherwise you can change it. Which brings me to my next point about the other functions here, that you can, once you have 2 windows open, this provides you the opportunity to either cascade your window or to have them side by side, or like in different particular, like in order which you want, which is needed in quite some time in some modules. I would always suggest to keep this view open so you know how many windows are being used currently. All right, so this was signal group module. We didn't make any change in this case. We can save and close it, and we can go to our very quick overview of the facilities module. This is just about documentation, where you give the number and appearance of signal heads, and they're documented in this module. So for signal group 1, what are the heads you see, or what will be the indication which would be seen on the signal? You can simply click here, and then you have possibilities to change different signal heads. And not only this, you have further signal heads for different countries. So yeah, but this is not needed for the engineering part. This is more for the documentation part. And this is something you can see how quickly, just by making basis data, we can directly go into our planning part for now. For that, I will open the variant 2. And if you have people who are following and also not quick enough, can just simply go on the variant 2 and click on it and come to the planning part. Here we have conflicts, which are right now empty because we did not import them. And of course, I will not do it for the click along. It will be tedious and too much time, but we can just do it for the first row for you to get an idea how it is done and what are the exceptions. So what you see here for V1, which is here, what are the conflicts? As you can see, V1 has a conflict with V2. So we click on this, double click, and it makes a conflict, which is all automatically reflected on V2, V1. Then you have conflict with V3L, then with V4, and we have with B3. As you see, this here is B3 and it has a conflict, and A3. And this doesn't have a conflict with P4 because we call them compatible, so with conditionally compatible, the turning traffic and the pedestrians. So we keep the conflict open for them. And similarly, if you have time and you can see this video later, you can complete the entire matrix on your own. I mean, this is what one of the parts of traffic engineer. And once we have completed this, it will look something like this. So this is the version with completed conflicts. Once we have all the conflicts, it is now the step to calculate the intergreen times. We save and close, and we go to intergreen time calculation here. This is how your window will look like once you open it for the first time. Intergreen time basically is the needed time between the end of signal group green and the start of a conflicting signal group green time. So the conflicts which we define in the last stage. And we here, the intergreen time will be calculated just based on the inputs we have given right now, the geometric data and the conflict matrix. So it's just one button. We just have to click on calculate, and Lisa will calculate it for us. I click on this button, calculate. We are using the German manual for calculation of intergreen time. Here, each column represent, so a distinction is made in the intergreen time calculation based on the signal groups. Then you also have the stream conflicts, so if it's going straight or left or right. Then you have the substream conflicts. So if it is, maybe I can open basic data side by side for a quick explanation here. And then you see here the conflict points. So you can have just the signal groups, then you have the lanes, then you have also the type of mode. There could be different conflicts points for different type of modes. And then also there could be different conflict points for all these three categories, right? So for all these, Lisa has calculated the clearing entering time and given us the intergreen time. So as I said, this is German manual what we are using. And even in Germany, you have various possibilities to calculate intergreen times depending on different cities. You can have intergreen time greater than yellow. You can have it greater than equal to yellow time. There are many parameters to play with. And this is nothing right or wrong. It is just a different approach which a city uses. So Lisa basically provides you numerous opportunities and numerous possibilities to play with. How to round it, and also the speed which you have to consider for each direction, the parameters for public transport, and also for vehicles and for bicycle and pedestrians. So this could be changed in the settings. If I close it here, you have a possibility to change your length of vehicle. For example, if there is road outside a truck facility with 12-meter vehicle, it will have a different intergreen time. So you can make one more row, add one more row, and then just change the length of vehicle here, and a new intergreen time will be calculated. Then you can also see if the intergreen time is calculated because of bicycle, because bicycle was the decisive one in making this calculation. And this might help the planners to maybe create another signal group just for bicyclists. And then you can always add if there is something at the edge. It's always good to be safe. For example, you see 8 seconds here as intergreen time. You can always add 1 second more, 9 seconds, and you will see that it's protected and it's in blue. So Lisa is telling us that this is the change which you have made. All right. Once you are happy with your intergreen time, you have checked it, rechecked it, you can fill your intergreen time metrics. And there is already one intergreen time matrix which exists. It's asking me if I should overwrite it. I don't. And if I go here in the next one, this is my intergreen time metrics between my signal groups. You see the minimum green time needed between the conflicting signal groups. Okay, so these were the safety measures. This, in theory, you can already start creating a signal timing plan based on the safety procedure. Of course, we don't have something to evaluate our signal plan if it is good or not, because we would need the traffic flow. But just to show you that here you can already calculate with minimum green times, and we don't have any flow. We go next. sorry, I calculate here. I clicked here on calculate STP in the signal timing plan module. So if I was too fast, planning, signal timing plans, and here I click on calculate STP, and it will calculate based just on minimum green times, which we gave, and the intergreen time matrix. So it asks us, we will consider the intergreen time matrix, which I have given in. And then, of course, we cannot evaluate because we don't have any flow. And then I click on next. And Lisa will calculate one signal timing, various signal timing plans for us. Type 2 done. And this signal timing plan is based on the minimum waiting time. I think I didn't show it. I'll do it again. Minimum green time. Next for now. And you see there are 52 plans which are created here. And we can select from, you can see the waiting time here. It's 6081. So it already chose the one with the minimum waiting time for us. All right. We have created one signal timing plan based on safety measure. We cannot evaluate it, but what we can do is we can click here and change, increase, decrease the green time. And we'll go now back to create flows, so it will be more clear what we can do with the signal timing plans. I don't save it, and then we go back to configuration and evaluation parameters. Here you will enter the traffic flows. So we can add flow here. And as soon as we create a flow, because you see these are not highlighted, I can click on plus. This window appears, and I can write, for example, morning flow. Okay. And then just for example, so here we can keep our sketch open, and then or if you have some data already, you can simply enter here, and you will see how this diagram looks like. It dynamically changes with the input. And now we have this from to matrix graphically represented in Lisa. What important for evaluation is for each of the flow, when you click here, you can give the vehicle distribution, which will be used in the evaluation calculation. So if you know how many are the trucks, buses, and so on, you can provide them here. So simply clicking here, and then you write the distribution of the modes. And if you don't know them for all the modes, and you just know for the heavy good vehicles, which is very much important, then you can provide it here. In that case, this will be highlighted and this will be grayed out. So similarly, you can create one more flow. I will not do it. I'm just showing you example, and you can say, you can make it on base of morning flow and then say it's 1.5 time of the morning flow. All right. Then there is something called parameters. So here you can check one by one, clicking on each lane, the properties of each lane, if they are correct, or if something has to be changed, if there's a triangle island to be given in, if there is a crossing which you have to provide in. These all are used to evaluate the level of LOS for the signal groups. Okay, and here you can check if there is an island there, what is the length of the lane, and so on and so further. All right, so once we have given in the flow, we can now go back to signal timing plan, and now the signal timing plan will make more sense. I will do now, close, say no, and go to an example where I have given in the evaluation data. So we have here 3 traffic flows given in. And once you click here, you will see how it is distributed among different modes. I close here, go to planning, and then click on the signal timing plans here. I will calculate one more STP, and now you can choose from the flow which were defined before. Yeah. You can choose a cycle time if you want to. I mean, it's important when you are doing in a coordinated corridor where you have this limitation that it should be the same cycle time, but here in this individual intersection, I can just skip it. Then it has already chosen the intergreen time matrix. I have not done offset, so I can just leave it for now. I'll show you later. And then we can use the HPS 2015 to evaluate our signal time plan, and I do next. Now we see a signal timing plan has been created for us with a cycle time 81 here. There's something here, and using this algorithm, we got a signal timing plan with minimum cycle time. I said done, and this is created for us. And as now you can see, we have LOS here for level of service for each of the signal group. And if you want to increase something, we click on this and we can try to change it without impacting the minimum green time or the intergreen time metrics. Because if I do that, let's say I do this here, normally you should see the violation of intergreen time. So Lisa will tell you that the intergreen time has been violated, and it will show you an error. All right. Yeah, there will be some warnings here, which you will see that intergreen time are violated between the signal groups. And then you can, this is the automatic creation of the signal timing plans, but you also have a possibility to create them manually, which is of course not a good approach, but just to say that Lisa provides you this possibility, you can select the demand here, and then you can manually give in here how much do you want to give the timing in and out. And yeah, just manually writing in here, and then you can use these functions to drag them and play with them. You have something like here where you can click on this and increase cycle time completely. And then here you can, instead of writing them manually, you can use the set initiation time and click here. So instead of clicking here, you just click on this and initiation time is set for you. Another feature to be seen is when you click on the intersection diagram in this case, and when you click on the level of service, then you will see this colored level of service to provide you a better understanding of how your intersection looks like. You can see it for all of them, and if you change it, it turns into a better green color. There's also a possibility to see how this level of service has been calculated. You can just simply click on the evaluation here, and then you have the entire steps written for you, how it was calculated to A. You can go, in fact, one step further. You right click on this, you click on log, and it tells you all the steps for each leg and lane, how Lisa came up to this level of service. Of course, this is for the HPS 2015, but also for others. Once you have created your signal timing plans, it is important to put the activation plan and deactivation plan. This is basically when your controller is turned on. It will start with an activation plan, and Lisa can do it automatically for you. You just have to click on Create AP, and then you can choose which calculation method you want and for which signal timing plan you want to create the intersection activation plan, and you click on OK, and a new activation plan is created for us. So it means when the controller is off and it turns back into it's turned back on, it will start into this, it will switch into this activation plan before it goes into the signal timing plan. And similarly, you can do with the create and deactivation plan, where you when you switch off the controller, so same process, do OK, and Lisa automatically, just with one click, calculate the deactivation plan for us. When I show you the test site, I will make sure that I show you this quickly, so you get an idea of what this is. All right. And once you have put in the activation plan, deactivation plan, there is something which we have to define, which are called the deactivation points, deactivation point, and switch point. I think this could go into detail. I will also show you this when I show you the test site. What you can see also on the right side, when you click on the signal timing plan, all the properties of the signal timing plan, if it is fixed time, if it's traffic actuated, and what are the Intergreen metrics used in this. So this was done without the offset, which I skipped right now, was something called offset. We go here to 3. So offset are basically rules which you can define for non-conflicting signal groups, and which basically tells you, okay, I want to start this signal group 2 seconds before the other signal group. Or if you want to have 2 signal groups to start at the same time. So, and they would be then used in the automatic signal timing calculation to calculate the signal timing plan. For example, in this case, let's say I want that V1 and V3 should start at the same time. So what I can do is just provide V1 equal to 0. So it means that the green time of V1 starting, the initiation time should be equal to the initiation time of V3. And if you want that some signal group starts before or after, for example, if you want, let's say here, let's look at the map and we say that the pedestrians should get green 1 second before the V3 comes in. So we will just say V2. So here it should be greater than 0. So this means that P2 will start, and this can start, the V3 can start maybe 1, 2, 3, 4 seconds later. And if you say that it should start 1 second after this, then you can provide equal to 1. And similarly for end of green, it says when it should end. So if flashing light should end 12 seconds after the pedestrians have stopped to cross. So because if pedestrian is crossing and it is already red and he's on the middle of the way, then the flashing should go on 12 seconds more than when this pedestrian is off. So we can say that FL2 is, for example, 12 seconds more than P2, something like this. These are the rules which you provide for the non-conflicting signal groups for calculation of your signal timing plans. So they will be included in your signal timing plans. Okay. I close this offset and go back to the variant I was working on. And this is how your offset will finally look like with all the rules which you provide in. So it means V2 and V4 are starting at the same time. P2 should start before V3. Or FL2 should start 1 second before V3. And this will be included in our signal timing plans. So here in this case, we have the offset inside, and you can see, for example, V1 and V3 should start at the same time, if it is, or end at the same time, depending on the offsets which we have given in, or V1L. All right. So until this here, we have created intersection using Lisa S. The next step is going to Lisa M, where you can also just not work on one intersection, but in fact, in a coordination of a corridor. For that, we will, first of all, I have an example here. I think the people with demo version also have this example with Lisa Town. We go on coordinations in the direction west and click on here, and all the intersections will open in this selection list. Just if I remove all these entries, if I go here, you see that the coordination mode is not highlighted if I just have one intersection selected, because of course coordination need more than one intersection to be coordinated. And when I go here on the direction west and stop it, save it, then coordination is active. But I think what will be nice to also explain how to make this, if you don't have this example for some people, remove all entries, I can click on new coordination variant, And then you can give your, for example, training 1, direction west, and direction west 2. Empty, let's make it empty. And then this window's open, and this asks us to put all the intersections which we want to put in the coordinated corridor. And you see all the intersections here on the left. I will go with the Lisa Town examples here, 7, for example, 1, 2. So I simply open them and click on them here. So, and now you can go here and try to put them up and down as per they are geographically on the map. And once you click OK, this is created for us. And now you can work on the similar thing. So people who didn't have it's already created, that's how you create a coordination variant. I will remove it and now go back to my version here and then go to coordination. And we open the coordination module. This is a time distance diagram. So on the y-axis here, you see the time in seconds. And on the x-axis, these vertical lines, what you see are the intersections, what we have given in the project management. If you want to look at the basic structure, when we normally create a new variant, this is the first window which appears. So these are the intersections which I have given in the coordination, and these automatically suggest us the signal groups in the direction of travel and the signal groups in the opposite directions. So of course you can change it, but more often than not, these are correctly suggested. Then you have to provide distance between these corridors. You can of course use Google Map, check the distance, and you can provide the distance between 2 neighboring corridors. So this is for the direction of travel, and this is for the opposite directions. Here you can provide the default information and the directions. Important is this here for the travel distance diagram. So based on this basic structure, you have here so all the intersections which are being created. Maybe I can create a new variant for you to see how this will look like. We click on plus, and then when I click on plus, this TDD2, time distance diagram 2 has been created. You can change the name. We can say it, let's say click along. And then for all the intersections, it shows we have various signal timing plans. It shows with the cycle time 53, only the intersection 667 has, it doesn't make sense. There's no coordination. So we have to choose similar cycle time for all the intersection. What if I do 75? When I do 75, all the intersections have a signal timing plan 2 with cycle time 75. And similarly, can I make more choices? No. So they have just signal timing plan 2. And when I do 90, I have various signal timing plan to choose from. So let's say we keep we do 3, or we choose signal timing plan 3 for all the intersections. Right now we have so if you remember, we opened all the intersections in coordination. So that means if I open some other module, let's say if I want to see the signal timing plan, Lisa will ask me which intersection do you want to open? Because we have so many intersections open here, and I want to check, for example, 677, 667. So these are the signal timing plans which were shown here in case of 667. And only 1, 3, and 11 has a cycle time of 90. So, okay, and then I go back here, and it has created a travel time distance diagram for me. So you see here, it was very important to that we see that the order of intersections were correct. So this diagram makes sense for us. And here you see this 50, which means that a vehicle coming here at the speed of 50 will approach the another intersection at this point. What we can do here is now we can click on this, check the properties, change the speed if you want to, or we can try to optimize it based on various factors. We can either do it manually, which is, of course, it doesn't make sense, but here you can go up and change the offset, change how you can see, you see how this green window for V2 is changing to see if we can provide more vehicles passing from here till here without stopping. We can visualize this platoon with bands, which I will show you. But before, just the properties of these of this distance time distance diagram, which you see here. You simply click on this. Or for example, let's do something which is disturbing our green wave. Let's say this one here. Here, if I click on this, I can move up. And you can see this goes up. Okay. I can also let the green band to be visualized. If there is a green band, in this case, maybe there is no green band, and you can see how the green, all the vehicles which will start here and go till the end. Okay. All right, so there's no green band in this case, but let's see we can evaluate these. All the bands will be visible, but I don't know, it's taking some time. Okay, just for simple, because coordination is one big topic in itself. For click along, I think it's just good to keep it simple. Here, as you see, the new coordination which I created, this has this, you can evaluate based on this LOS. So you see it's not the best, E and D. You have this waiting time and for the entire intersection, and separately for each intersection, you can have a look here. Then you have performance, and we have various parameters to evaluate our coordination. You have something called performance index, which is basically tells you the fuel consumption. So the lower the value is, the better this consumption. And then you have something called coordination measure. This is from a German manual, which tells you the ratio of passage without stopping, so ratio of intersection where without stopping to the number of intersection where it stop. And then you have also the stop percentage and the waiting time. So this is what happened when we did it manually. Let's say I want to optimize it in the best way. So we do get coordination that we have these best parameters, the optimized parameters, and we can have these signal timing plans for each intersections. We don't have to do it manually, move it 1 second on the top or bottom for each of the intersections, which are like numerous possibilities. So we have an algorithm which does it for us. And I click on this here, and I choose which flow I want to select. Let's say morning flow. Sorry, I close it. I want to see which flow I was using for this here. So it should be same. Okay, that's why it should be morning flow here. And then I will click on this morning flow. Next. And it asks which evaluation criteria you want to optimize. Let's say we do it for CC, like coordination criteria in both the directions. And normally you should give 100 or something like this, but for click along, we keep it 25. I do next. This ask which coordination variant we want to optimize. I put it here, and then do next, and let's wait for it to find us something hopefully better than this one. All right, it has created us with coordination criteria of, okay, done. And here, so you look at this LOS, which is much better than what we did manually. So Lisa, using its downhill simplex algorithm, has created for us much better coordination variant by changing all the signal timing plans. And if you want to compare with this one, you see for all the three we did it was 60, 52, 73, and in our case it's 95, 94, 97, which means percent of intersections where the vehicles are crossing without stopping. And the LOS has also increased from D to E. What we can now have a look on is on the green bands, you can see the platoon which goes through without stopping in all the intersections. much more advanced thing, which I can also quickly show you here, is you can also have a possibility to look on the platoons instead of the band in the direction of travel. Because platoons don't make much sense. It is a very traditional way of using a TDD, but here when you have the knowledge of, okay, what is the density of the platoons, how many are the vehicles which are waiting from the last time in the red, which will join the platoon after the green, or which are the vehicles which will be joining from the turning side, which are turning into the main direction. So all these information you can have a look here and go further and further in detail to see how it is calculated and what could be used from it. And once you click on it, you will see the information here about the density, about many things, which we will not go in detail right now. And a similar thing, you can do it for the opposite direction. Okay, once you are fine with the signal timing plan, I will just 1 second try to remove this. Display, okay. All right. So once we are fine with our optimized coordination, I will add it to my coordination. But you see there is still this red symbol here. What will I do now? I will say I'm okay with the signal timing plan. I want to create this new signal timing plan for all the intersection. So I click on this button, update STP. This window opens and it says that what do you want to do with new STP? You want to overwrite the existing one, or new, or discard? So let's say new, and I call it the click along. So same here, new, and I change it, new. It's interesting to see it, how it will look like there in the intersections, and then I do it CA. All right, and it will have ID number 4. Okay, so now Lisa is creating a new signal timing plan based on this screen time in our intersections. So let's go to any of this intersection. We go here. Let's say we go here. And this click along has been created for us here. This is the one based on the coordination. Of course, this was very quick, and there are many factors more which could be considered, but just for you to get an idea how it looks like. And yeah, that's a very brief overview of coordination. This is included in Lisa M. And there is a special training just for coordination, a day training if you want to go more into details. And the next thing which is included in Lisa M is time switch. So what we showed, first I will go back to this here, all entries, and go back to my example. So we created some signal timing plans. Of course, I've not shown you stages and stage intersection. That's part of Excel. I will quickly also show that later. But we have created some stages with activation plan and deactivation plan. The next point, what we can do is provide a time switch in controller, which tells at what point of the day which signal timing plan should be turned on. So if I do here, I can say in morning, you turn it on, and then at, I don't know, or at 5 in the morning, you can say it turns on, and then in 7, it goes to a signal timing plan 1. And then similarly, you can change based on in the noon, you want to switch to signal timing plan 2. So you can define this time plan for your planning. And this, for example, this here, I can say edit, and I can call it weekdays, let's say. And then you create something more, new day plan, and you can call it weekend. And weekend, you can provide similar thing that you are, just an example, you turn it on, and then, sorry, yeah, that's better. And then you switch it to add 9 o'clock to signal timing plan 2, something like this. And then in week plans, you can just say that Monday would be my weekday plan, Tuesday weekday, and Saturday you want to have your weekend plan, and Sunday you want to have your weekend plan. So this will automatically be then given into controller, which we'll see uploading shortly. And then you can also define some special days. If you have, for example, in your countries, you can import some special holidays and you can put them in the weekend plan. So, for example, if you have New Year, you can insert it here, or you have, I'll just show you some example. You close it, and then if it is a movable date or not, or if, and then here you can assign this. These all are weekend plans. So controller automatically knows that even if these days are falling on a weekday, it will follow the plan of the weekend. I hope I was not too fast with the time switch, and I click OK, and then it is saved. And we can save and close it. All right. So this was time switch. This is all covered in Medium. And the next module, which is Excel. Before I go to this, maybe a quick summary would be nice. What we did after the basic data, we created the evaluation parameters where we gave in the traffic flows. We check the signal groups. All the information is correct. If you have to change some symbol, if the minimum green time, it is the initiation time and termination time is in accordance to what is followed in your country, city. Then you go to the planning already. You check the conflicts if everything is correct. Sorry. And then you go in the Intergreen time calculation, click on calculate, cross-check it, double cross-check it, because this is the main safety parameter. You can change things here, you can change the settings here, and then once you're fine with it, you can fill your Intergreen time matrix. Then you open your Intergreen time matrix. You can create more matrices here by adding on this plus symbol, and this will be used in your signal timing plan. Once you have created this, you can also create some rules for non-conflicting signal groups, where you tell what signals group should start at the same time or before or after. Similarly for end, you provide this information here. Then we go to signal timing plan creation. There are various ways to create your signal timing plans. Either you can do it manually by simply clicking and using these icons here, or you can let Lisa do it by clicking on calculate STP, giving your flow in. If you have some desired cycle time, then it chooses the Intergreen time metrics and the offsets what we have given in. And then how do you want to evaluate your signal timing plan and so on. And if you click on next, a new signal timing plan will be created. Once you have created your signal timing plan, you can go to settings. This is something which maybe I've missed, so good for an overview or summary. You can go to settings, go on columns, and here by maybe flow ratio, want to see. Okay, and then you see your flow ratio, or depending if you want to see your level of service, I think this is much more interesting for you to see. Click here, and then you see a level of service. And once you click here and you click on this, you can also see the colors, how it is. And then you have a possibility to change your Intergreen time. And then we created an activation plan and deactivation plan, which will be used in the controller. I will show you in the test site. All right, that was all for the Lisa S and M. And now quickly for the XL is the traffic actuated control. So the great feature of Lisa is that it supports a variety of manufacturer where you can directly upload the control which you developed and also tested in Lisa with the test site without any changes, let's say. You see this thing here, we can directly upload it. Depending on license what you have, you can upload it to various controllers directly or to similar simulation software. You see we have various options here which you can upload to. Let's go to traffic actuated. So how it looks like, you click on the logic. Of course, this half an hour is not enough to show what logic is, but just to have an idea what you can do in this. So how do we get things running in controller development environment? So it might look a graphical software, but in actual, it is being developed to source code internally. You have Java, C++ internally. And even traffic engineers with no programming experience can define these flow diagrams with some standard libraries, which are already in Lisa. You just have to use these functions. And these libraries are understood by controller. This is internally converted into source code. Whatever you write here, it will be converted into source code and given forward to the controller. So we have some controller functions in Lisa when you click here. And this is an overview of all the controller functions which we have in Lisa. They might look very cumbersome right now at first view, but these are basically asking, for example, if you see, click on this stActive. So you just have to write this function stActive. It is just asking Lisa, is my current stage active or not? Sorry, I think I completely forgot one thing about showing you the stages. Before I go into logic, there's something very much important about which is used in traffic actuated is stages. Here you define all the signal groups which are not conflicting in one phase or stage, however you want to call it. I will for now delete them to see how you can make them. You have this window open and then you click on plus. I need 3 stages, 2, 3. So we click on these 3 points, phase 1, phase 2, and phase 3. You can make 4 or 2, whatever, how the traffic engineer wants to make it. And then here in phase 1, you tell what all signal groups do you want to be in phase 1. So you right click here. And once you right click here, automatically the conflicting signal groups will be crossed. So they will not be in this phase. Then let's say we also want V3 in this one. And let's say this will be our main direction. So we can also have P2 and AL2 in our case. And FL2, of course. Similarly, for phase 2, we just want the turning vehicle. So we say V3L. And what was now phase 2? I put it here. I mean, doesn't matter. V3L. And then we can say we also have the other V1L in this case, because it was the one with non-conflicting turning motion. And phase 3, we can have only for the, let's say, only for the minor direction. So V3 and no, that was not V3. It's always good to have your side diagram open, intersection diagram open to see what we are. So V2 and V4. V2 and V4. Once we have these, we can, of course, make them change this font, make them bigger, smaller, because this is also used in documentation purpose. Make them more beautiful, let's say, change even from circle to, I don't know, square. I know some countries use square. And then it's important to select a phase and then tell which one is the activation phase, so activation stage. Once you have created all the signal groups in the phase, it's important to connect them. So for the stage transition, so you say, okay, I'm okay from stage 1 going to stage 2 and stage 2, stage 3. So how traffic actuation is actually working is just it's working on these stage transitions. It checks in if the minimum green has been reached or if there is no intergreen time violation, change to different stage. So these stage transitions are actually the basic stones of traffic actuated. So like stage timing, like the stage timing plan, you can automatically calculate also the stage transitions. Lisa will do it for us. So you click on stage transitions and automatic ST generations, and it will create all the combinations possible for us. So what it considers is that minimum green time is reached and also the intergreen is not violated between 2 phases. And once you have this, you will see in the logic now how they are used in logic. And you can also use them for creation of signal timing plan, but we don't discuss it here for now. Okay, now I go to logic. All right, so I was telling you that Lisa automatically converts all these diagrams, blocks, what you are creating into a source code, and which you can compile. I can show you how basically this logic work. I can create a new function. So normally you need to have one main logic in your control, in your planning, which is called every second from the controller, which basically check what is being executed this second, which is basically checking how if the current stage is active and what we have to do if there is a demand from another stage. Maybe I'll create one example for you to understand what I mean. And also this will explain these building blocks. So I click on here. Let's say I call my function again to click along. All right. I have a function called click along. You see, this is how it looks like. I will close this window for now. You have these blocks here. And I want to see if my stage X is active right now. So this is a decision control, which will answer in yes or no. I click here and I ask if my stage X is active. And it will have two exits, which will be yes or no. If yes, then we will check if this stage need to be extended. So we say, I mean, I'm just giving you an idea, the idea behind this actuated control. And then it's stage to be extended, let's say. Of course, these are not variables, so Lisa is telling us what is stage, what is B, what is extended, because these are functions for that which we use. Stage should be extended. If you say yes, it has to be extended, then you do nothing. You just keep on running the stage because it is already active. So let's say do nothing. And what if this stage doesn't need to be extended? Then we check if there is a demand on another stage. So we check, all right, if this doesn't need to be extended, but is there a demand on stage Y is demanded? So if stage Y is demanded, then what we do is we start the stage transition to stage Y from X to Y. So we say start the transition from X to Y. And if stage Y is also not demanded, what we do is we do nothing. We just keep on going. And then we do here, let's say we do nothing. So this is how basically the idea behind this function is. Maybe I can click on end so it looks nicer. And here. All right. So this is the idea behind this logic. And for the stage X active or stage to be extended, we have functions in your controller functions. So when I say stage active, so instead of writing is stage active, you use this st active, and then you write the name of the phase. And if yes or no, if it is yes, then you go stage to be extended. How do you check the stage to be extended? You check the detectors which were defined. If that detector, the extension detector, is still occupied, the stage has to be extended to a certain extent. Of course, it cannot go green forever. So you always give a maximum green possibility, maximum green time. And then it checks here if has to be extended, then we do nothing because it's in the same stage. And if it doesn't have to be extended, we look at the minor directions. In few cases, actually, the major direction can be always extended. There is no limit, but yeah. And then we look at the minor direction. If there's a demand on the detectors, if there's a pedestrian pushing button, then we switch it from X to Y, and here the stage transition come into place. So once you are done with your logic, you can compile it here with various compilers you have in here, and then you can test it. I'll show you how we can go to test site and how you can check it. But first I will delete this because Lisa will show me error. So this is how the function I made looks like. If it is active, if you have to extend it, and then you set the transition from 1 to 2. Okay, and in pre-logic, you are checking if there is a demand on detector for, yeah. Okay, once I have created this, I save and close, and I show you the test site quickly, which is. So once I'm done logic, I can compile it and I see if there are some errors or not. Normally there should not be errors. And once you don't have errors, you can compile it here. It's compiling using the Java JDK, and there are no errors. So now we can I can close it, and I can go to my test site. One thing too, which I didn't mention in the basic data, when you go in basic data, here you can click on, if you have Excel, you can click on the simulation conflicts, and then you can click on the simulation network, and you click on OK. Then this simulation network will be automatically created for us. All the detectors, all the signal group will be allocated at the right positions, as you see here. This is our control panel on the left side, where I can choose the signal timing plan, which I have to run. I apply it. If you right click on here, you can also choose which traffic flow you want to simulate. So let's say we do this for the morning one, and I run it in real time. And I change to the graphical protocol. So the controller will start from the activation plan, which I wanted to show you before. I will pause it and show you. Maybe we can go step by step further. All right. And I go back to my signal timing plans. And here is the activation plan. And you can see that this is the plan which started in the beginning. So that's how, when you switch from control, you turn on your controller to a plan, this is the first plan which runs. And then it will go to the signal timing plan 1. And yeah. This is too much to to handle, I know, but just for you to get an idea that Lisa has this test site where you can also see your signal timing plan, but more importantly, you can debug your logic. So once you have this here, you can open your logic side by side. Here is where these windows come in handy. You can make it side by side here. Yeah, why is my graphical log behaving in such a way? Then you can click here and see where is currently your logic, how many times that logic has been called. You can see the numbers, in fact, in Lisa 8. And then you can always check where you are currently. You can also set debug points. So your Lisa stops there. People who are a bit familiar with programming know what debug point is. And yeah. And very interestingly, you can see side by side visually, create a test, click on the detector manually to see how your logic is functioning. For example, if I stop it and I go here, yeah. So you have option to click on it like this, and it will look something like, if I run it, it'll be faster. And I make it here, and you see I have here detector. So if I keep on clicking on it, it will show that I am clicking on D8. So it comes like in your graphical protocol. You can set your own test. There's numerous possibilities what you can do here. You can change the signal timing groups here. You can create your own test that you want. After every 10 seconds, you want to click on a detector because you have created some logic which will be used, which you want to debug. That's why there's a possibility of create test. Then you can also create your own network if it was something wrong, some additional thing you want to put in your network. So you can just go in the editing mode and you can use the following options to create your nodes and connect them. Then there is a possibility to see here, like to have watched values, which signal timing plan, which detector has been called for, since how much time is the detector on, and so on. Great. So this is something which is available in Lisa XL now. And something we have extra to show is you also have the possibility to, I mean, this is the signal timing plan covered. You have the logics, traffic actuated control, test site, and then you also have, based on this German manual, to evaluate the unsignalized intersections. Maybe this is not interesting for people outside Germany, but yeah, this is the first step where you evaluate the intersection if it actually also needs a traffic signal timing plan. I think I covered everything. I hope I did not forget something. No, it doesn't look like. Maybe extra point here with the detectors. Once you have the Excel module, all the detectors which you have covered in basic data here will be shown in this window, which I can show you again. I close it in configuration detectors. You have all the detectors, type, the leg, the distance, and the signal group and the function. And you can change their functions in this table. And if you want, these settings will be further used in the logic. For example, deletion time 3 seconds. If a detector is occupied more than 3 seconds, what to do, or what is the maximum time gap. So if you want to extend a signal group, then you look at this value, 3 seconds. If there is no vehicle passing for more than 3 seconds, then you start the transition for other direction. So all these values are given here, which will be checked in the logic, and there's something called malfunction. For example, if a detector is occupied more than 300 seconds, so it means, I mean, you can give more if there's a traffic jam normally for 300 seconds, which is very not likely, then there is something not working in the detector is faulty. So this is what you give here. And if you are interested in more detailed training, then we have Lisa's training basic, where we will explain in details until the creation of signal timing plans, fixed signal timing plans, and also Lisa Excel in English. And we have the extra trainings for Lisa Map, for CITS, and so on.
Thanks a lot for joining us today. And as always, we are at your service if you have further questions. Please contact us at service@schlotauer.de if you have any technical questions, or if you want a quote, an offer, have any sales-related questions, then please contact us at lisa@schlotauer.de. Thanks and have a nice day.